me forget to take them off for lunch. Why? Sorry, it's not about how they look. I don't care how they look. It's like the people that don't have glasses. Just because they're fat.
Just go along with
Okay.
Oh, can I try them on? I can see through them.
I'm reading it. So it's first things close up because my glasses are fine for everyone.
Attention.
Who we? I'm ready now.
Sorry.
I've got everything set up, like camera's going on. Yeah, no, it's all good. Let's get some precise stuff in there so that you can carry on with your conversation again later on. All right, so we're looking on page 6 now, for those of you if you haven't quite turned up to that page in your book. And we're looking at what's the difference between elements, compounds and molecules. Is there anyone who feels confident that they could tell me what any of those things are? What's an element or what's a compound? Or
An element is something that's made up of one type of atom.
yeah, okay. Element, one type of atom. That's exactly right. I won't ask you what an atom is, but yes.
And a compound is made up of multiple elements, or one.
Yeah, okay, so a compound, 2 or more elements. But not just that, there's something else about compounds.
They're chemically bonded.
Yes, they must be chemically bonded.
Yeah, it's fine.
Because if I've only got one type of element bonded together, like as if they come together, it's still an element because there's only one type of atom present. So I have to have 2 or more for it to be a compound. Which begs the question: what's a molecule?
Is it when the elements like fuse together, travel in a group? I don't really know. It didn't come out right. Let me start again. It's like what you were just saying, like when you have 2 oxygen, they travel together. That's a molecule.
Okay, so they're traveling together. They're like buddies. How can we express that more scientifically? I know what you're saying, and I think you know what you're talking about, but I guess it's not really using that scientific language. Anyone? Yes.
So they're like atoms combined together chemically, but they're like as one particle thing.
Yeah. Okay, so the way I would describe this is a molecule is a discrete particle. Alright, so you're right, when you were talking about your oxygens joined together to make oxygen gas, that's exactly right. And our carbon dioxide gas that we were looking at, the dry ice that we looked at last lesson, exists as a discrete particle, a molecule. Not everything is a molecule. Okay, so this is a particular kind of bonding that we will look at in a few weeks' time. So some compounds are chemically bonded together in the form of a molecule, and others are chemically bonded together and they don't form molecules, they form something else. Anyone got an idea of what the other kind of compound could be? If you don't know, that's all right, because I'll teach you that later. No? Okay. All right, so let's just leave it at that. So they need to be separate particles to be molecules. All right, on page 7, here we are, we're looking at these elements, and yes, Jackson was right when he said that an element is a substance made up of only one type of atom. And we can look on the periodic table. We've got one on the wall over there. And we know that if we encounter atoms of potassium in Greece, that they're going to have the same properties as atoms of potassium in Australia. So they're the same everywhere. And that they have the same, each unique element has the same number of protons. All of our elements are on our periodic table, and I think we talked about this last time too, didn't we? That there's no gaps in the periodic table for undiscovered elements. That we've filled it in. Now, what we can do now for questions 7 and 8 is get you to answer those questions where you're going to look up some elements on the periodic table on your formula sheets and write down that difference between an element and a compound. All right? And you may phone a friend